This is the third lecture of the Chemistry Lovers Organic Chemistry course, and this is actually the beginning of the course because the previous two lectures were the foundation. Now, in this lecture, I will be discussing about different electronic effects and how they contribute towards the reactivity of a molecule. So, stay tuned and let's start our today's topic. So, electronic effect. What is electronic effect? Electronic effect is a very important concept in organic chemistry because that will decide the reactivity of a molecule. Electronic effect means the distribution of electron in a chemical bond around different atoms, and the different electronic effect actually decide whether a particular atom will acquire electrons or it will lose electron, and that will in turn dictate whether it will react or not, and if it react, uh, to which species it will react and how fast it will react. So all these things depends on electronic effect. If we talk about electronic effect, there are namely four electronic effects. One is inductive effect, then we have resonance effect, we have hyperconjugation, and lastly we have field effect. We will discuss all these electronic effects in this lecture, and if you watch this lecture till the end, I can promise you that you will have a proper understanding of the topic and you don't have any doubt left. So first we will talk about inductive effect. Now before understanding inductive effect, we should know what is electronegativity. So the concept of electronegativity comes when two different atoms are bound in a chemical bond, and then what will happen? So one atom that will have higher electronegativity, it will drag electron from the bond or drag electron cloud from the bond, and it will acquire some negative charge, partial negative charge, whereas the other atom will acquire partial positive charge. In this case we have used the example of HCl molecule, where chlorine is more electronegative than hydrogen, so chlorine acquires partial negative charge and hydrogen acquires partial positive charge. So this is called concept of electronegativity. Now how it leads to the inductive effect? So inductive effect is when some atom is attached to carbon, okay, and then that atom, if it is more electronegative than carbon, it will pull electron from the carbon, whereas if it is less electronegative than carbon, then it will push electron towards the carbon. So groups like silicon, any silicon based group or alkyl group, they are less electronegative than carbon, so that's atom. Why they will push electron towards the reference carbon atom, and we call it plus I effect or positive inductive effect. And in this case carbon atom acquires partial negative charge because it is gaining electron, and the atom which is pushing the electron, that will acquire partial positive charge, okay. But when some electronegative atom is attached to carbon, for example OH group, OR group, or NH2 group, or any halogen group, so what they will do, they will drag electron from the carbon because they are more electronegative than carbon, right? So in that case carbon atom will, so the reference carbon atom will get partial positive charge, and the atom which is dragging electron or pulling electron like halogen or other atom, they will acquire partial negative charge. So this is called minus I effect or negative inductive effect. So this is all about plus I effect and minus I effect. Now we have to remember few important points about inductive effect. So first of all, inductive effect, as we have seen, it operates through the sigma bond, right? And because it operates through the sigma bond, it depends on distance. So in the example you can see fluorine is pulling electron from the carbon skeleton, and the atom to which the fluorine is attached, that carbon atom is acquiring the most amount of partial positive charge. And if we go to carbon number 2, the intensity of the positive charge decreases, and in case of carbon number 3 the intensity is even lower, and after carbon 3 there is practically no effect. So inductive effect depends on distance, and up to 3 carbon atom there is the inductive effect, although for carbon atom 1 it is highest and for carbon atom 3 it is lowest, and after carbon atom 3 there is practically no inductive effect. The second point is because in case of plus I effect, the groups push electron towards the carbon atom. So any group that shows plus I effect, that will stabilize a positive center like carbocation. In this example, we have used the tertiary butyl cation. Similarly, because in case of minus I effect, groups pull electron from the carbon, so they will stabilize the negative centers like carbanion, in this case trichloro uh, trichloromethyl group. Okay, so this is very important. When we will discuss about carbocation and carbanion, we will see this in more detail. Now the next topic of our discussion is in resonance effect. But before going into that, I want to give you remembrance of our one topic from our first lecture. So in the first lecture, in chemical bonding lecture, we have seen this thing in case of conjugation. So when we have a group having lone pair or group with vacant orbital, when they are attached to some pi system, they come into conjugation with the pi system. In the first case, it is OH group which is having lone pair, and in the second case it is nitro group which is having vacant orbital. So they come into conjugation. Now how this is linked to resonance effect. So in case of resonance effect, what happens? So if a group with lone pair is linked to some pi center or pi network, then what will happen? That group will push its lone pair or electron density into the pi system, right? And that's how the pi system gets a extra electron cloud or extra negative charge, and we call it plus R effect because it is pushing electrons. So any group having lone pair like OH, OR, NH2, SR, all this group having lone pair, they can show plus R effect or plus resonance effect. This effect is also called mesomeric effect and plus M effect. But when your pi system is attached to some electron deficient group or group having vacant orbital, for example carbonyl, any carbonyl group, it may be ketone, it may be aldehyde, it may be carboxylic acid, it may be your ester, or like nitro or nitrile group. So what they will do, they will drag electron from the system, pull electron from the pi system, and this is called minus R effect or minus M effect, minus resonance effect or minus mesomeric effect. And so this is all about resonance effect. Now when we talk about aromatic rings, aryl rings, so aryl rings are very important or very interesting. You can see aryl rings, they can show both plus R effect and minus R effect depending on whether they are attached to a positive center or a negative center. So in the first case, the aryl group is attached to some negative center, so here it is pulling electron from the negative center and it is showing minus R effect, whereas in the second case it is attached to some positive center and it is pushing electron towards the positive center and it is showing plus R effect. Now this is very important because if you introduce some group in the aryl ring, for example in the para position, if you introduce a let's say OMe group, then it will be a more of a plus R group because now the OMe group will also push electron, right? And if you put a nitro group, then it will drag more electrons, so it becomes a minus R group. So selecting the group, you can tune the reactivity or you can tune the electronic effect of these groups. Same goes with the allyl group. You can see similar like aryl group, they can both show plus R effect and minus R effect depending on the situation to which they are attached to. If they are attached to negative center, they shows minus R effect. If they are attached to positive center, they shows plus R effect. uh, but in case of vinyl group, they cannot show resonance effect. So the arrow whatever I have given is actually wrong, so it is not possible. Why it is not possible, that you can understand if you look into this structure. So this is molecular orbital diagram of a vinyl anion or vinyl cation, where the red sp2 orbital, in case of vinyl anion, it represents uh, mm, orbital with two electrons, and in case of vinyl cation it represents a vacant orbital. Now you can see that vacant orbital or orbital with electron, that is actually perpendicular to the pi system and not parallel. So that's why it cannot come into resonance with the pi system. So resonance is not possible here, right? Because parallel arrangement is a must requirement for resonance or conjugation. In case of phenyl cation also, you can see this resonance is not possible, because here again the electron is in the sp2 hybrid, or the vacant orbital is actually the sp2 hybrid, and that is perpendicular to the pi system and not parallel, so resonance is not possible here. So this is very important. Okay, now there are some points which we have to remember in connection to resonance. First of all, unlike inductive effect, in case of resonance the effect does not depend on distance, because it is operating through the pi system and pi bond and not through the sigma bond. So this is, in this example you can see OH group is pushing electron into the pi system, and whatever the amount of negative charge on carbon 2 is same with the amount of negative charge on carbon 8 or carbon 4 or carbon 6, because it is operating through pi system, so distance is not a factor here. So at any point the amount of plus R effect or minus R effect is same. The second one is resonance effect is much more stronger than inductive effect. Inductive effect is relatively weaker in comparison to resonance effect. Third effect is because plus R effect is push electron into the system, it will stabilize positive it will stabilize electron deficient centers like carbocation. So in this case OMe group, it is stabilizing the adjacent positive center. Similarly minus R effect, because it pull electron from the system, it will stabilize negatively charged center. In this case the nitro group is stabilizing the adjacent anion center. So these are the important points about resonance effect. Now our next thing is captorative effect or push pull effect. So we have seen that when some group with lone pair is attached to pi system, it will push electron, and some group with vacant orbital or low energy orbital is attached to pi system, it will pull electron from the pi system. But what will happen when both are attached to the same pi system and they are connected through that pi system? So that is shown in example 1. You can see the NH2 group is pushing electrons into the aromatic ring, and that electron is actually pulled out by the nitro group, right? So there is an extended conjugation from the NH2 to the nitro group through this benzene ring, through this aromatic ring, and this is called push pull effect or captorative effect. Similar effect is seen in example 2 and example 3, where in example 2 the lone pair in the ET2N group is actually delocalizing into the ester group, and in case of example 3, both lone pair on sulfur and lone pair on nitrogen is actually delocalizing into the nitrile group. So this is called captorative effect or push pull effect. This is very strong effect. uh, the next is hyperconjugation. So we have seen inductive effect, we have seen resonance, now it is hyperconjugation. Hyperconjugation is also known as no bond resonance or sigma donation. So what happens here is, if you have a positive center and if you have an adjacent CH bond, so what happens is that CH bond donates its sigma electron towards the positive center. So that is shown by example 1, where we have a tertiary butyl cation, and the CH bond is donating its electron into the positive center, the p orbital, the central p orbital, and which is shown in the orbital diagram picture. So you can see the CH sigma bond, it has two electrons in the bond, so it is donating its two electron into the p orbital, that is vacant p orbital. So this is called sigma donation or no bond resonance or hyperconjugation. And not only in case of carbocation, hyperconjugation can also occur with a pi network or with a aromatic ring. Okay, so hyperconjugation is relatively weaker effect, and in comparison to inductive effect or resonance effect, but in some cases it plays deciding factor. So what will be the reactivity, that will be decided by this hyperconjugation. We will see that in our course. Okay, so this is all about hyperconjugation. It is basically sigma donations, donation of the sigma bond to adjacent positive center or pi center. Now our next thing is, or the last thing of this lecture, is field effect. What is field effect? So whatever we have discussed till now, that effects are operating through either sigma bond or pi bond. Okay, in case of hyperconjugation also it is operating through a kind of sigma bond. uh, Actually this is forming a pi bond later, but it is operating through a bond. But in case of field effect, it is truly a effect which is devoid of having any bond, so it is operating through space and not through bond. So space is important here. So if we consider molecule 1 and molecule 2, they are two acidic molecules, but pK of molecule 1 is higher compared to pK of molecule 2. That means molecule 2 is more acidic. But if you look into the structure is almost same, only the difference is in case of molecule 1 the chlorine atoms are in the right hand side, and in case of molecule 2 the chlorine atoms are in the left hand side. So why there is a difference in the acidity? So to investigate that, we have to look into the stability of the corresponding conjugate bases. What is conjugate base? Conjugate base means the anion part of the acid. So when you remove proton from the acid, that becomes the conjugate base of that acid. So these are the conjugate bases for molecule 1 and 2. I represent it by 1 prime and 2 prime. Now if you look into molecule 1 and 2, you can see, so I have opened up the structure of C double O minus, the anion part. Now in case of molecule 1, you can see the chlorine atom is actually negatively polarized. It is called dipole moment effect or dipole effect. So it is negatively polarized, and because the chlorine atom and the C double O minus group are in the same side, so there is a coulombic repulsion between them. So this is a coulombic repulsion between them, which is represented by that red thing. But that kind of repulsion is absent in case of 2 prime, right? So 2 prime, the conjugate base of molecule 2 is relatively more stable compared to 1 prime, where we have coulombic repulsion. So that's why 2 will be much more acidic than 1, and that is manifested in their pK values. So this is called field effect, because you can see the effect is operating through space and not through bond. So bond is not involved here, only space is involved here. So this is called field effect. Sometimes it plays very important role. So this is all about our today's lecture. So what we have learned from our today's lecture is different kind of electronic effects and how they regulate the reactivity of a molecule. So that's all. Thank you for watching. If you have any doubt, let me know in the comment section. I will answer them.